Hi Professor, we will talk about multiplexing types. We will together, my friend Seyfullah Tangal and my name is Samet Toltar. You can start.
Multiplexing types. Content multiplexing is the process of combining multiple data sources and transmitting them over a single communication channel. Widely used in telecommunication, internet data transfer, wireless communication, and satellite communication. What is the multiplexing? Multiplexing is the sharing of a medium or bandwidth. It is the process in which multiple signals coming from multiple sources are combined and transmitted over a single communication physical line. Uses of multiplexing. Multiplexing is used for variety of purposes in data communications to enhance the efficiency and capacity of networks. Here are some of the main uses. Efficient utilization of resources. Multiplexing allows multiple signals to share the same communication channel, making the most of the available bandwidth. This is especially important in environments where bandwidth is limited. Telecommunications. In telephone networks, multiplexing enables the simultaneous transmission of multiple telephone calls over a single line and changing the capacity of the network. Internet and data networks. Multiplexing is used in internet communications to transmit data from multiple users over a single network line, improving the efficiency and speed of data transfer. Satellite communications. Multiplexing helps in efficiently utilizing the available bandwidth and on satellite transponders, allowing multiple signals to transmitted and received simultaneously. Types of multiplexing. There are three different types of multiplexing techniques, each designed to handle various types of data and communications needs. These techniques include frequency division multiplexing (FDM), time division multiplexing (TDM), code division multiplexing (CDM). Frequency division multiplexing. Frequency division multiplexing is defined as a type of multiplexing where the bandwidth of a single physical medium is divided into a number of smaller, independent frequency channels. Frequency division multiplexing is used in radio and television transmission. In FDM, we can observe a lot of inter-channel crosstalk to the fact that in this type of multiplexing, the bandwidth is divided into frequency channels. In order to prevent the inter-channel crosstalk, unused strips of bandwidth must be placed between each channel. These unused strips between each channel are known as guard hands.
And this is code and representation. Time division multiplexing (TDM). Time division multiplexing is defined as a type of multiplexing wherein FDM, instead of sharing a portion of the bandwidth in the form of channels in TDM, time is shared. Each connection occupies a portion of time in the link. In time division multiplexing, all signals operate with the same frequency at different times. There are two types of time division multiplexing: synchronous time division multiplexing, statistical or asynchronous time division multiplexing. Synchronous TDM is a type of time division multiplexing where the input frame already has a slot in the output frame. Time slots are grouped into frames. One frame consists of one cycle of time slots. Synchronous TDM is not efficient because if the input frame has no data to send, a slot remains empty in the output frame. In synchronous TDM, we need to mention the synchronous bit at the beginning of each frame. Statistical TDM is a type of time division multiplexing where the output frames collect empty slot like in synchronous TDM. In statistical TDM, we need to include the address of each particular data in the slot that is being sent to the output frame. Statistical TDM is a more efficient type of time division multiplexing as the channel capacity is fully utilized and improves the bandwidth efficiency. This is representation TDM and code Code division multiplexing. Code division multiplexing is technique used in the telecommunication to allow multiple users to transmit data simultaneously over a single communication channel. In CDM, each user is assigned a unique code that is used to modulate their signal. The modulated signals are then combined and transmitted over the same channel. At the receiving end, each user's signal is stimulated using their unique code to retrieve their original data. In CDM, each user is assigned a unique spreading code that is used to spread the data signal. This spreading code, this is typically a binary sequence that is much longer than the original data signal. The spreading code is multiplied with the data signal to generate a spread spectrum signal that has a much greater bandwidth than the original data signal. The spread spectrum signals of all users are then combined and transmitted over the same channel. At the receiving end, the received signal is multiplied with the same spreading code used at the transmitting end. Because each user's data signal is split using a unique code, it is possible to separate the signals of different users even though they are transmitted over the same channel. CDM is commonly used in wireless communication systems such as cellular networks and satellite communication systems. It allows multiple users to share the same frequency band and increases the capacity of the communication channel. CDM also provides some level of security as the signals different users are difficult to intercept or jam. This is GDM code and representation. Advantage of multiplexing: efficient use of bandwidth. You can send more than one signal over a single channel. This way, you can use the channel's capacity more effectively. Increased data transmission: multiplexing can significantly boost the amount of data that can be sent over a network simultaneously and enhancing overall transmission capacity. Scalability: multiplexing allows networks to easily expand and accommodate more data streams without requiring significant change to existing infrastructure. Flexibility: different types of multiplexing TDM, FDM, VDM, GDM and can be used based on the specific needs and characteristics of the communication system, providing flexibility in network design.
Disadvantages of multiplexing: synchronization uses, ensuring that multiple data streams remain properly synchronized can be challenging, leading to potential data loss or errors if not managed correctly. Latency: combining multiple signals into one can introduce delays as each data stream needs to be processed, synchronized, and demultiplexed at the receiving end. Signal degradation: over long distance, multiplexed signals can experience degradation and inference requiring additional measures such as signal boosters or repeaters. The main quality: resource management, allocation and managing resources for multiplexing can be complicated, requiring careful planning and real-time adjustments to avoid congestions and assure efficient operation. Conclusion: multiplexing is a key technology in data communications that helps to make the most out of available bandwidth by combining multiple data streams into one. This process allows for more efficient use of resources, reduces cost, and increases data transmission rates. The main types of multiplexing include time division multiplexing TDM, frequency division multiplexing FDM, wavelength division multiplexing WDM, and code division multiplexing CDM. Each of these techniques has its own unique way of managing and transmitting data, making them suitable for different types of communications needs. Overall, multiplexing plays a crucial role in assuring that our communications networks are fast, efficient, and capable of handling the growing demand for data transmission.
That's all. Thank you for listening.